Hi, we're going to run through some quick refresher on a few of the basic Excel charts. And the relevance here is what I call establishing the scoreboard. When we have some data, some of us may be able to visualize it just by the numbers, and sometimes that may be the best way to do that. But other times it may be worthwhile to put it up in a little bit more of a graphic presentation so that we can tell this, we can understand what's going on, tell the story to others, and either make a decision on the future or have some good dialogue on what we ought to do. So I like to make the analogy that we have a scoreboard every time we go to a game, whether it's a basketball game, a soccer game, etc. We have scoreboards somewhere, and really that's a lot for the coach to be able to see what's happening in real time and make decisions on what players that need to be in the game, what strategy, what plays, those kind of things, what changes need to be made, if anything, in order to win the game. So we want to establish a scoreboard. So we're going to begin with categorical variables. We know we have two types, categorical and numerical variables. Categorical is that one where it's either one or the other. So like we are going to begin with by saying that we've asked your college students what type of music they like the most. And so we get the following kind of responses: that they like rap, pop, metal, and a little punk, maybe. And we get these kind of responses out of a survey that we do. And so before we even begin charting anything, I always think it's a good idea to get in the habit of that simple frequency table, which is not a chart, it's a table, but we want to kind of know what we're talking about. So first, how many people gave us responses in the first place? So 145. And in this case, this is a sample, 145 of the amount of people at York College, again, roughly 4,000. So we know what we're talking about here. And then, so this is the number of responses. And then this is the frequency of responses within our sample. So I have a feeling I'm going to be visited here pretty soon.
Hello.
Are you sneaking up behind me?
Hello.
All right, I'm making a video for my students. You want to say hello?
Hello.
All right, this is Logan. All right, bye. Okay,
Hi.
so we want a 57 divided by 145. There we go. And just to kind of clean things up a little bit, we're going to format this column. All right, so we're looking at 39% there, and we're just going to drag that down. And that showed up because we didn't lock that sum. And now that we've done that, we should be able to drag this down, no problem. There we go. So we can see before we begin to chart this that pop and metal really combined, 39 plus 32 equals 71. The majority of the people like either metal or pop. And between those two, it's just about split. So 39% to 32. That's quite interesting. So if we want students to come to an event and we give them a sample playlist of the kind of music or bands that we're going to have there, and they're metal and pop, if this sample, if we did everything else right, and this is indicative of the entire population, if we have metal and pop bands there, and even those that blend those genres, that's probably a pretty good decision to make. Conversely, if we have rap and punk, we might not get the turnout we want to get. So that's how this information is useful even so far. Now, let's start with a little bar chart, okay, which is the primary way of depicting categorical variables. You can't go wrong with a bar chart. And we are going to select the variable column and the number of responses. So this is the x-axis, and this is the y-axis. And we're going to play with our bar chart until we get it that way. I'm running the Mac version of Excel 2011. If you have a PC, then you probably have a more sophisticated way to depict this chart. But on a Mac, here's how you do it. You want to say insert chart, and we're going to go tier to bar. And so this gave us the genres on the y-axis, which is okay. We can alter this chart to show it differently. All right, so there we go. We can depict it this way, or we can switch it to this way. Okay. Personally, I prefer this way, although I've seen it both ways. So here visually, this helps us understand what's going on. And by the size of this column right here, we can see how much it's bigger than pop, and then how much it's bigger than rap, how much it's bigger than punk. The big key with bar charts is we have to begin at 0. If we began at 10, we wouldn't get that proportionality that we need to and that we get by starting with 0. Quite simply, in this example, if we started at 10, punk would just drop off and we wouldn't even see them at all. But we wouldn't, it just wouldn't do these differences justice. So that's the bottom line on a bar chart. Got to have 0 at the bottom. If you're looking at something with a bar chart that doesn't have 0 at the bottom, it's either faulty presentation or they might be trying to hide something. So from here, we're going to transition, again, categorical variable to the Pareto chart. Now, the Pareto chart was developed by a gentleman named Pareto, and it kind of goes by this 80-20 principle. And it's just a pattern, kind of like other patterns in life that he had seen. And so it's not always true with 80-20 per se, but it kind of, the purpose of the Pareto chart is for one to gain an idea of where they should prioritize effort and resources. That's my opinion. So it's often used with complaints or errors. Again, a categorical variable is the type of complaint in a certain area, or the number of errors in a certain area. Did a system fail due to power? Did it fail due to processing? Did it fail due to human error? Those kind of things. Do we have complaints in the dormitories about air conditioning, furniture, security, those types of things? What do we know about unhappiness in the dormitories so that can help us prioritize effort towards what to do about it? If we know that there's a lot of complaints about air conditioning, if we fix the air conditioning problem, then we'll reduce the amount of complaints the most. So let's just run with that example. Let's say that we are looking at how to spend money on renovating the dorms at York College. And so we look at the number of complaints. Again, we survey some students, and we find out air conditioning. I will just put HVAC for heating and air conditioning. We'll put security. We'll put paint, furniture. And we'll just say we have numbers that look like this. And we want to do a Pareto chart so that we can understand where to prioritize effort. Now, again, sticking with old habits or new habits, whatever way you look at it, I always like, again, to establish our frequency table even before we begin, just so we can understand what we're talking about. So sample size of 177. And we do this like we just did. And drag that on down. Clean this up. Okay, so the bulk, not 80 like Pareto would say, but 44% is from painting. So again, if we prioritize painting, we'll take away 44% of our complaints. We won't take them all, but if we were to prioritize furniture, that might not be a very good investment in energy or resources, because 94% of our complaints are, folks are going to say, that's great, but hey, you didn't address the things that I wanted you to address. So we got a better shot at investing in painting, assuming, again, that this sample is indicative of the larger population. Pareto chart looks just like a bar chart with some slight differences. So the quick way, we want to establish, grab these two. We could grab all three columns. Doesn't really make a difference. We want to go to Insert, Chart, Pareto. Okay, this is a little tricky to interpret. Let's start by looking at what we already know. Okay, so painting, there it is. 78 is the leading source of complaints with the dormitories. And that's what a Pareto chart is going to do. It's going to stack the sources from highest to lowest. And that's whatever way you do this, whether you ask Excel to do it for you or you do it yourself, it's going to look like this. That's the first thing. So in that regard, it's somewhat of a bar chart. Here's the differences. This line and this axis right here. This is a supplementary axis that shows us the percentage. And this line is a cumulative percentage line. Now, just to make this a little more clear, cumulative percentage is, as we add these up, what they add up to. So first thing, let's make this, and what I'm doing right now is really for the purpose of instruction, not necessarily just for the clarity, so to speak, of instruction. Okay, so my frequency table over here matches what I'm seeing over here, with the exception of this orange line, this cumulative thing. So manually, the way that I set up a cumulative column is that this first row is going to be that right there. So if this is frequency, this is cumulative frequency. And of course, this is the number of responses. So this is going to be that pass number plus the one for the row that it's in. And because I didn't lock any of those down, I should be able to drag that down. So in other words, and this is, we got to be careful about how to interpret this or explain this with categorical variables. So we can say that between security and painting complaints, those complaints together account for 75% of the 177 responses. That's how we interpret that. And by the same token, between HVAC, security, and painting, those three categories account for 94% of the responses. In a cumulative column, our bottom cell should always be 100 or 100%. We've accounted for everything. Okay, that's not the Pareto chart. I just put that in there to make my data up here match this down here for the purpose of this video and explaining it in clarity. So back to this orange line and this axis right here. This orange line is a cumulative percentage line. So when we look over where it appears in the painting column, it appears right a little bit around, if we trace this over, and this is where it's hard, we're looking at the relationship of this line versus this axis. And if we were to trace it over, it intersects this axis here at about 44%. So painting, that 44 matches over here. Now again, when I created this table, I didn't have to have this column. Okay, I can create this table based on these three columns. Okay, and I think even these two. So security, when I go to security and I look at where this dot is, okay, I'm not tracing this way, I'm tracing over here, and that dot for security intersects this axis roughly around 75. Again, security and painting together account for 75% of the responses, and so on and so forth. So this orange line is potentially kind of confusing. It's not the bars themselves that line up with this axis, it's this line that's there. In summary, this is a cumulative percentage line. This is a cumulative percentage axis. Personally, I don't really like interpreting it that way. In reality, the value of this chart would be for me to say, hey, painting is greater than all the others. How much greater? Well, percentage-wise, I would be looking at this column. It's 12% greater than the next, or excuse me, 13% greater than the next closest one. So the person in the crowd that wants to get new furniture and think that's going to solve students' complaints is probably kind of wrong. I really wouldn't listen to them. So that's a Pareto chart. Again, we use that with categorical variables. Okay, and that helps us prioritize effort. Finally, we're going to talk briefly about the pie chart. Now, the pie chart is really not liked and is not a preferred method of depicting data by a lot of people. Pie chart kind of has a bad rap. So let's just look at it really quick. And the donut chart is a version of the pie chart when we're talking about two variables. 177. So I don't even think we need this column. We'll just see. We'll go to insert chart, pie, see what it comes up with. Right. So we can always improve this. A lot of the reason people don't like the pie chart is just it's kind of deceiving, especially if you don't start things at 12 o'clock, okay, at the top here. So in this pie chart, we see between the yellow and the blue, this line here is starting at 12 o'clock. And kind of like the Pareto chart, it's loaded the largest in there first. Of course, we have it that way. I don't think it automatically does that. Let's just see what it looks like if we do these. Of course, there it's smallest to largest. So this would be the kind of the opposite of what we just saw. Probably not the best way to depict this And then furthermore, without the percentages on there, it gets kind of confusing about what, like this blue piece, what is the relationship of that versus the orange? Of course, in this program, we highlight over it, we can see that. But if we're putting that up on a screen or something like that, or sending this to someone, they might not be able to mouse over this like we can. And so it just kind of gets confusing. Not really preferred method to depict these things. Folks are a lot more comfortable, I think, out in the real world with bar charts because there's a lot more points of reference available. It's a lot clearer what proportionality is. So let's see if we can just turn this into, or get rid of this and see if we can get a donut chart in there. Of course, a donut chart is kind of a version. Let's see, maybe we need some more data. There we go. There's our donut. Yeah, so equally problematic, or even more problematic, because it's depicting two samples. So we'll say maybe this was a sample we collected last year, and this is a sample this year. Of course, number one, we kind of would want to sum this up and kind of see, and we'll see that, these numbers are not the same. Not that they have to be. Does it make a difference that we got that many less responses this year than last? Does that allow us to still compare answers? Maybe, maybe not, and we'll talk about that later in the course. But, we can kind of see that the orange from one year is less than the orange from the next, but really this is just kind of a mess. People don't get it in a matter of seconds. There's a lot of explaining we have to do. I would actually say in this instance, when we had data like this, it would be a lot easier to explain it even than the table itself. Or let's just go back to our old friend, the bar chart, and do this. And see what that looks like. So if blue is series 1, and of course we can change all this. If blue is 2018 and orange is 2019, we can see how much the painting went down from orange to blue. But how much the HVAC became a problem in 2019. So that's really where, if we were focused on painting in the past, well, it probably made a difference, but now we have a new problem to worry about. So this chart is a lot better in telling us, assuming that we fix our series names, so one says 2018 and one says 2019. But you can see that this chart is a lot more beneficial into telling the story than that donut chart, which is just kind of a mess. So that's why the pie and the donut charts aren't really preferred in terms of establishing scoreboards. So, quick review. Bar chart, most commonly used. Pareto chart helps us identify where we should prioritize effort and resources, as does the bar chart. Pareto chart is a little more specific. And then pie and the donut chart, not so well and not so preferred as the others. Okay, so that's it for categorical variables.